So today's all about graphing square root functions. Exploration 1 on page 307. Go ahead and take a look at that. First thing that we need to do in order to graph square root functions, make a table of values for each function. Okay? So I want you to pick some values for x. Go ahead and solve for y, and that's going to help you graph it there. No graphing calculators used on this, please, unless you're just calculating square roots. Okay? Off you go.
I can't do nothing.
It is okay. Yeah, you can. Okay. So as we start going through these and putting these in, when I pick some values for x, so what's the first value you guys picked?
1.
4.
Okay, so we're at a bunch of zeros. Let's start with 0. If I put 0 in, square root of 0 is 0. Notice I'm going to put my work underneath here. Okay? What happens if I put, well, let's put 1 in. That means the square root of 1, which is tough to find, right? So rather than doing a decimal, how about we pick a number that would be a nice square root? Oh, actually, 1 is actually okay, right?
Yeah.
Sorry. Let's take root 2. Does that one work? No. So what's the next nice square root? 4. So use the nice ones. 4. Which is? 2. And the next one we'd want to use then is? 9. Yeah, so we put 9 in. Root of 9 is? 3. Okay, now notice my scale here only goes to 10 on the graph. And 10, so looks like we could probably stop there. So my coordinates are 0, 0, x, y, 1, 1, 4, 2, and 9, 3. Notice on the bottom there, I'm just showing my work. Okay, so I've got my 0, 0, my 1, 1, my 4, 2, and my 9, 3. Now, we know that this graph will keep going, so we put an arrow on the end. Does it keep going this way? Do I need an arrow down here? Tell your neighbor yes or no. Why? Why not? There. They say, yep, it will. I would say, nope, it won't. Why won't it? Yeah. Yeah, the values over here I'd have to put in, I have to put -1 in for x. Okay, and when I put -1 in, that means I have root -1, and you can't do the root of a negative. So this doesn't exist. Anytime you get a root that is negative, it doesn't exist. Therefore, they're not going to exist for our negative x values. It stops here. You do not put an arrow there. If you put an arrow there, you have incorrectly graphed it. Okay? When we are describing the domain, remember domain stands for x and range is y. When I'm describing the domain, I am saying where does it exist using the x-axis as my measuring stick. So where does this graph begin to exist in relation to the x-axis? At 0. And from there, is it increasing up the x-axis or decreasing? Increasing. So x is greater than 0. Can it be equal to 0? Looking at our table, yeah, 0 worked. Okay? It could be equal to. That's our domain. As far as the range goes, that's in relation to the y. Okay? So range will be in relation to the y. So that means on the y-axis, when does it start existing? At 0. Okay? And is it going up the y-axis or down? It's going up, meaning it's greater than 0. Can it be 0? Yes. In fact, you see those 2 points in your table there. That is your range. Okay, notice I didn't finish the table because the reality is I couldn't put those points on the graph, so I just stopped there. Okay, part B. you guys to work on that one now. We'll work through one together. Try that one. All right. Hey, as you're going through this, I'm going to make my work area down here again. Now, I want my root. Notice I'm not putting anything in the root. I want my root to be root 0. I want it to be root 1. I want it to be root 4. And I want it to be root 9. What's the next root I want it to be? 16 and 25. Now, the deal is, I can't use these exact same values to get there because I'm adding 2 in there now, right? So, if I'm adding 2 to get to 0, what does x actually have to be? Negative 2. So they're adding 2 in here, so really we need to go 2 less than what this is. This one won't fit, right? But if we're finishing the table. Okay, now by doing that, negative 2 plus 2 is 0, and root of 0 is 0. Negative 2, or negative 1 plus 2 is 1, and the root of 1 is 1. 2 plus 2 is 4, and the root of 4 is 2. 7 plus 2 is 9, the root of 9 is 3. 14 plus 2 is 16, and the root of 16 is 4. And 23 plus 2 is 25, and the root of 25 is 5. It's kind of weird. Like, if you start noticing, look at your y values. Those are the ones that go up by 1s. And your x's are doing the goofy stuff, right? Yeah, it's almost backwards, yeah. So we get negative 2 and 0. We get negative 1 and 1. We get 2 and 2. We get 7 and 3. And we get 4 and 14. It's not going to fit. So just go here. We know that 4 is actually going to be at 14, so we don't cross over this line for 4. Okay. There we've got it. What's our domain here? Yeah, so on x, as Jason just said there, it's negative 2, right? So we look at our x-axis. It's negative 2. So Jason, are we getting bigger or smaller? Getting bigger. How about range? Yeah, range, y is greater than or equal to 0. Starting at 0, going up. Hey guys, this graph right here is a transformation of this graph. So I'm going to make you make yourself some notes here. This graph right here is called the parent function. Everything starts at this graph. This is like the run-of-the-mill, normal, ordinary, boring square root graph. From there, we transform it. Okay? So this graph is transformed from this graph. How did this graph change from this graph? Tell your neighbor how these two change. Okay, if I called this y sub 1 just to distinguish between the two, if this is graph, actually let's call this, I'm going to change this to f of x. And I'm going to change this one to g of x. Okay, how does g change when compared to f? Yeah. Go ahead. Yeah. You're adding 2. Yeah? Good. So Gianna says we're adding 2, and that's inside here. So that's how the equations change. In terms of the picture, Kai says it's a horizontal translation. Translation means you slide. So we're translating it. I'm not going to make us say horizontal, but that's good. Translating 2 units left. So translating 2 units left. We should say which one is translating 2 units left, F or G? G. G is translating 2 units left. Okay. Nothing else is happening. That plus 2 in there, that means it's going 2 units left, which is kind of weird because you think of plus 2 actually moving.
Right.
Right. Everything, when you're inside here with X, inside the parentheses here, everything is backwards. So if it says plus 2, you're actually going towards the negatives 2. If it says minus 2, you're actually moving to the positives 2. It's everything's backwards. Okay? All right, how many think you got it? Okay, let's try this one. Take a look at exploration number 2. This one's a tougher one. If you can do this, I'm going to be impressed. This is good stuff right here. Tough. Write a square root function that has those values for f of x. In other words, those are your y values now. Come on, I know a handful of you have it for sure. All right. Hell no. Hey, let's focus right here. If I tell you f of x is equal to the root of x, well, if x is -1, that doesn't work. How do I get from -1 to 3? Yeah, I add 4, right? Oh. That would now be x is equal to, or f of x is equal to the root of -1 plus 3 is root. What is that? -1 plus 3. It's 3, yeah. Right? So I get the square root of 3. Hey, what happens if I put, let's do it over here. Oh, did I say 2? -1 plus 4 is what I meant. I'm sorry. Okay, let's try this. If I go x plus 4 here, and I put 0 in, what's 0 plus 4? 4. What's the square root of 4? If I go x plus 4 here, what's 1 plus 4? 5, square root of 5. Well, let's make sure it works up here. What's x plus 4? -4 plus 4 is 0, and root of 0 is 0.
Oh,
so the function is f of x equals square root of x plus 4. Good. All right, Cassie? Tell you're like pumped about it. Calm down. Okay, what's -3 going to be then? Tell your neighbor what you got. Good.
Oh, no.
-3 plus 4, or root 1, which is 1. How about -2?
Square root of 2.
Very true. Square root of 2. All right. Hey, now that you know what to do, try the more difficult one, B.
Uh-oh.
You can do it. You be good at it. Hey, go back to this one right here. How could you get root 3 from -1? Ignore the 1. How could you get the root 3? Yeah, use this rule. Right? So if the 4 wasn't there, don't you scribble it out, but if the 4 wasn't there, you could use this rule again. But the 1 is there. So what do we have to do to that rule? Yeah, we have to put a 1 up. We have to say all plus 1. Okay? Well, you better make sure it works out on all these. Really, this is just saying I'm taking, this rule right here is saying I'm taking what I had over here and adding 1 to everyone. So if I took all these values that I originally had and added 1, they should match up. Okay? The only problem is this one and this value, the book actually misprinted. In my book, it says 0. In your book, does it say 0? This should be a 1. Right here. Alright, because it's always, all these values over here have to be 1 greater if we're taking the same rule, using the same inputs. So this would be what? 2. This one would be?
1 plus square root of 2.
1 plus root 2. Yeah, you can't add the 1 to the 2. One's inside, one's outside. You can't put them together. This one would be 2 plus 1. Good. And this one would be?
1 plus square root of 5.
There we go. All right. That was in stereo. That was awesome. Okay, so go ahead and answer question 3. What are some characteristics of root functions? What do they look like? What are some characteristics? What do we want to get? Okay, summarize that, and then we'll try some of these. It's just a place where you summarize what your understanding is of it. Well, we'll see.
We're going to have to do this if we have homework here.
Okay, well, let's try some of these. Hey, guys, I really would like to show you the quick way to do these. We can make a table every single time. Okay? We can also kind of learn some patterns involved here. Right? If we know that the square root of x looks like this, and it has this table, 0, 1, or 0, 0, 1, 1, 2, or 4, 2, 9, 3. Okay? When I'm taking this function, notice I've drawn my axes in here. Remember what we said about the minus 1. Which way does that shift our graph? It's backwards in here, right? So rather than going to positive 1, or negative 1, excuse me, we go to positive 1. And that means our vertex is shifted to here. Okay? This value right here tells you where your x value is, as long as that says 1x right there. Okay, so this is the x coordinate. If we just look at the 1, not the negative 1. Or if you think of it as whatever will make that 0, that's the x coordinate of the, you call that your vertex or starting point. I'm going to call it the vertex. Okay? And from there, I think if you want to build a table, it would help many of you out if you did your x and you said your root, and then you did a y down here, or a g of x in this case, if you want to think of that as y. Okay, what would I have to put in? Well, to make that equal root 0, which is what we're trying to do, this x would have to be 1, and that's why that's 1 there. And then square root of 0 is 0, so we get 1, 0. That's that coordinate. So if I want it, what's the next root I want? Not 4. 1 before 4. Yeah, 1. Not 3. No, the 1 before 4. Then we want 4. We always want to make the perfect roots. So how do we make root 1? Yeah, we put 1 in. 1 minus 1 is? No, don't put 1 in there. How do we make root 1?
You square it.
2 minus 1 is 1. Square root of 1 is 1. How do I make root 4? 3. How do I make root 9? What minus 1 is 9? 10. So it's 3 right here? No. What does that have to be? That would have to be 5. Okay, so if I'm putting my points in, okay, 1, 0, 2, 1, 5, 2, and 10, 3 is not going to fit. So we'll just call it good there. What's your domain? greater than or equal to 1. Notice it's always this value right here on the x-axis. It's always the x-coordinate. Your range is y is greater than or equal to 0. If we look at this value right there, that 1, 0, that's where those points come from. You just have to put the correct symbol in between. Okay? Huh? Yeah, that helps out, right? Compare it. How does this graph compare to that graph? Yeah.
In the one by the words, it's just you're figuring out the square root of the number. Instead of the one by a, you have to minus 1 first.
It's true. Hey guys, picture-wise, how do the graphs compare? Nope. How does this graph and that graph compare? That's our graph. Yeah. Almost. Translation. 1 to the. Yeah. This is a translation. 1 to the right. Okay. Hey guys, these problems right here, everyone have these axes drawn? You're going up by ones. Get those axes drawn right now. Okay. You also need to list to yourself right here, find the domain and range. All right. I want you to finish those 3 problems. About those on our next class. Make sure to draw those tables in. That'll help you out. Put that root there.